Okay, so I have a question here. It says, consider the following demand function QD equals 25 over P squared. Show that the point elasticity of demand for that function is always equal to 2, to negative 2. Right, so price elasticity of demand is how quantity demanded responds to changes in price. So for part A here, point elasticity of demand, this is the formula. We're going to derive the demand function with respect to P, which is price, and I'm going to multiply that by the price over the quantity. Okay, this is the formula for point elasticity of demand. Okay, so let's do this in parts. First, let's derive our demand function. Okay, our demand function is Q equals 25 over P squared. All right, so we can write this according to the laws of logarithms. This can be written like this: 25 p to the power negative 2. 25 p to the power negative 2. So when we derive, we always multiply the exponent by the coefficient. So say negative 2 times 25, you're going to get negative 50. Then you subtract a 1 from the exponent. So we're going to have negative 50p to the power negative 3. Okay, which can now be rewritten as negative 50 over p cubed. Okay, again, I've applied laws of indices. Whenever I've got a negative index, get the reciprocal. Okay, yes. Then we come to the second part of the equation here, P over Q. All right, so we know our price, when we put here P over Q, we know that our quantity, okay, quantity is 25 over P squared. So we're going to have P over, substitute Q with 25 over P squared as given in the question, because as you can see here, Q equals 25 over P squared. Okay, so how we simplify this, our denominator, okay, which is P squared, multiply it with the numerator. So P squared multiplied by P, that is P cubed over 25. Okay, let me just explain this part here. It's the same as saying P divided by 25 over P squared. So when we're dividing fractions, the multiplication sign changes, okay, and then it becomes P multiplied by P squared over 25. That's how we got there. P times P squared, P cubed over 25. All right, so now we've got our answers here. So bring it back to the here, the original formula. Okay, the derivative of our demand function, negative 50 over P cubed multiplied by P over Q. We simplified it, it became P cubed over 25. Okay, so these P cubes cancel each other out. Negative 50 divided by 25, that is negative 2. Okay, this is our point elasticity of demand. Okay, yes. We come to part B. The demand for good X is 300 units when its price is 4 kwacha. Assume that as a result of price fall, the demand for the good increases to 400 units and the sales revenue falls by 400 kwacha. The first part, calculate the price of good X after the fall. Alright, so for this question, we need to label our Q1 and Q2. So Q1 is 300 units. Q2 is 400 units. Then we need our P1 and P2. Do not have P2, so P2 will denote it as X. P1 is 4 kwacha. So first things first, let's get our total revenue. Okay, so we say TR1, or total revenue 1, is going to equal to P1 times Q1. That is 300 times, oh, that is 4 kwacha multiplied by 300. Our, our total revenue is 1,200 kwacha. All right. Then we've been told that this revenue drops by 400 kwacha. Okay, they've told us in the question here. Sales revenue falls by 400 kwacha. So since we're trying to get P2 here, okay, what we need to do is let's get our total revenue 2, our new total revenue. Okay, TR2. Remember TR2, which is our new total revenue, is our old total revenue, which drops minus 400. Since it drops by 400, that's why I'm saying TR1 minus 400, because this revenue is dropping by 400. We already have our TR1, which is 1,200. So if this revenue, 1,200, drops by 400, our new total revenue is going to be 800 kwacha. All right. So since we have our new total revenue, we can now get our price, our new price. Remember, TR2 equals P2 multiplied by Q2. Our new total revenue, 800 kwacha. P2 X, Q2 400 units. To get the value of X, divide both sides by 400. And X, which is our P2, equals 2 kwacha. So our new price is 2 kwacha. Okay. So first get the original total revenue. Once you get that original total revenue, subtract it by the decrease, which is this 400 decrease, to get your new total revenue. Once you get your new total revenue, you can get the price of the good that you are, the new price of the good. Okay. Part 2 of the question. Part 2 of the question says, calculate the price elasticity of demand with respect to the fall of price. Okay, so price elasticity of demand, PED. Let me put this side here. Price elasticity of demand is percent change in price or percent change in quantity demanded over percent change in price. So you're going to say here PED percent change in quantity demanded over percent change in price. Okay, so how we get these percent changes? We'll put it like this. Okay, let me just use this part of the board. That side of the board is not helping out. So let me use this side of the board. All right. Price elasticity of demand equals percent change in quantity demanded over percent change in price. How we get percent change? Okay, the new value minus the old value over the old value times 100. Okay, this is the percent change for quantity. The new quantity minus the old quantity multiplied by 100. How we get the percent change in price? The new price P2 minus the old price P1 over the old price multiplied by 100. Okay, so we already have this information here. Our new price and old price. Okay, we come back to information here. Our Q1, Q2, P1 and P2. All right, so let's get these percent changes. So the percent change in quantity demanded, the new quantity demanded 400 minus 200, minus 300, the old quantity, over 300. Now we can cancel out these hundreds here. Okay. Then the percent change in price, the new price 2 kwacha minus the old price 4 kwacha over the old price of 4 kwacha. Okay. So in our numerator, 400 minus 300, that is 100. 100 divided by 300, that is 0.333. Percent change in price 2 minus 4, that is negative 2. Negative 2 divided by 4, that is negative 0.5. So I'm going to say 0.33 divided by negative 0.5, 0.66. Okay, negative 0.66. That is our price elasticity of demand. Now, we have to get the absolute value. Why? Because due to the law of demand, when price increases, quantity demanded drops, and vice versa. So you're always going to be getting negative values. All right. So every time you calculate the price elasticity of demand, you get the absolute value, meaning you just ignore the negative sign. Okay. Yes. So the absolute value here is 0.66. And since this 0.66 is less than 1, okay, demand is inelastic. Okay, demand is inelastic. Since our price elasticity of demand 0.66 is less than 1, demand is inelastic, meaning it's not that sensitive to changes in price. Listen, price dropped by 50%, quantity demanded increased by 33%. So the change in quantity demanded was smaller than the change in price. Okay, yes. So this is our price elasticity of demand 0.66, the absolute value. And when the value is less than 1, demand is inelastic. Okay. Then finally, we've got this question here. Let me just make space here. Assume that the cross price elasticity of demand for good Y, which is a complement to good X, is negative 1.5. Calculate the proportionate change in the demand for good Y as a result of the falling price of good X. So cross price elasticity of demand is how quantity demanded of good Y responds to changes in price of good X. Okay, and that's cross price elasticity of demand. And the formula for cross price elasticity of demand is percent change in quantity demanded of good Y over percent change in price, okay, of good X. So here we already have our cross price elasticity of demand, which is negative 1.5. A negative cross price elasticity of demand states that goods are complementary, meaning these goods are used together, they're used hand in hand, right? Like a screen protector and a phone, okay? Like tea and bread, like a motor vehicle and fuel. Okay, by themselves, they're of less use, okay, but these goods have to work together. They basically think of them as a team, all right? So our percent change in the price, okay, they've told us, so with our percent cross price elasticity of demand negative 1.5, all right, then we want to find the percent change in the demand of good Y, so we're going to say, put it here, okay, over, let's see here, our percent change in price was 50%. Okay, this 50% here, that's the percent change in price. Okay, so we're going to put here negative 0.5. Okay, price dropped by 50%. Okay, from 4 kwacha to 2 kwacha, that's a 50% drop in price. Okay. Yes. So we want to find the percentage change in the quantity demanded of good. Why? So we cross multiply. So we're going to say x equals negative 1.5 multiplied by negative 0.5. Negative 1.5 multiplied by negative 0.5, we get positive 0.75. Okay, which translates to a 75% change. Okay. Yes. So that's that about cross price elasticity of demand.